Okay, guys, we have an issue. Due to the mass overcrowding of people that are actually like in our hotel, we have way too many people. We need to solve this out. The government is going to cut our funding, and we're going to be homeless again. You guys want to be homeless again?
No!
No. Yes.
Yes.
Okay, fine. All right. No, we don't want to be homeless. So basically, what we're gonna do is we need to have another pair of robots to go out in the field and to make our hotel bigger and to make a more suitable place for our residents to live. Okay, anybody have any ideas?
Oh my goodness! I have an idea. So my idea is we create a chain of robots using our Mach 1 and Mach 2 robots. So it's sort of like a train where the first robot senses and the second one follows and interprets that data.
Okay.
Okay.
So how are we gonna do this though?
So the Mark II will be using its laser rangefinder to scout the terrain and send signals to the Mark I, so the Mark I can follow safely.
Okay, I like this idea. Okay. So let's go get it done.
Okay guys, we have to start coding and programming our train of robots. So how are we gonna do this?
I think we should only use one robot because if you have two robots, that's twice as much maintenance between the two, between like the gear trains and everything. So.
Do you have anything to add, Ken?
I think we should also do only one robot because it's really expensive to do.
Well, I think we should do like divide like the simplicity, just because just by having one robot kind of like adds a lot of like mechanisms together. So if one thing goes wrong, you're gonna have to take apart all those mechanisms just to fix that one issue, as opposed to having two separate robots. And in addition to that second robot, we could like have it as a hauler to like haul all of our stuff and all like the materials and construction out to the construction site, and the first robot being like the maze navigator to tell the second robot where to go. So yeah, I think that's what we should use.
Yeah, I agree, because although it may be costly, I think it's worth it and it'll work better and be more convenient for us. So to decide whether or not we're going to use two robots compared to one robot, we decided to play a game of water pong.
Water pong. So what's the rules of water pong?
So the rules of water pong are basically whoever throws the most balls into that cup determines if we use two robots or one. So our first team is Cannon and Adam, and they are playing for one robot. And our second team is Noah and I, and we're playing for two robots.
Okay. Oh my god, it made it! It made it! It made it! I guess we have to do another round. Oh! Oh, we missed!
Woo!
We won. I guess now
Fist bump.
we have to do two robots.
Oh man.
Darn.
Yeah.
Okay, as we have right here, we have we have to import our necessary libraries, such as our time, math, motor imports, sound, buttons, that sort of stuff. Basically, just to get the robot going. So now we have the hardware set up, which creates our motor objects for our left and right motors. So basically, in a way, it turns like a tank. So if you know anything about a tank, for a tank to even turn, it controls the left motor, and it controls the left motor forward and the right motor backwards, and then collectively the tank moves a certain direction depending on where you want to go. And this is just setting variables. This is just going to initialize the tank and steering drive. This will create auxiliary hardware object. We're going to use it for our secondary, our follower robot, so we could follow our leader. So we have a color sensor that detects our surface color, and a ultrasonic sensor that will measure the distance from the front, sides, and rear, so we could actually like follow the maze and like figure it out. So as right now, so we have a turn left function, which will rotate the gyro angle when it reaches 90 degrees, and it'll reset before turning. And basically, just like I said, that basic tank motion, this is what it does. This is how it's going to turn left. Now this is going to be the exact same thing going moving straight. drive both motors at a speed of 20 degrees. Basically, we're gonna have 20. It's just a basic like, forwarding operation. It has to be slow just for the simple reason that when you're on Mars, you don't really want to go fast as lightning. So, you know, we have the same thing except the turn right. So just like turn left, we're turning right. So now we have the main program loop. So we're gonna continue moving until the color center detects blue, and then if the variable is false, then it'll turn right, or else it'll turn left. Hence, solving the maze. So yeah.
Guys, this is so hard. We can't figure out the gears bot and how it even works because we can't even add two robots in the same field and like collaboratively work together. Like, what are we gonna do?
You know what? Maybe we shouldn't have argued. That was a terrible idea.
So yeah, next time we can research how to work more cooperatively so that we're not always constantly arguing, we can understand each other better so that our project turns out better. So instead of arguing constantly, we can actually compromise.
Okay, I like this idea. I like where the train's moving. I like how a robot's balling. Tanner, what's your idea?
We're gonna study our videos that we were sent. We're gonna read our handbooks to make sure that we're getting the code right for our robots. Also getting other things that we also don't know yet and incorporate them in our robot. And we're gonna chat GPT everything. Yeah.
Guys, Coach is right. We learn the values of teamwork, communication, everything. We learn how to resolve our issues and compromise.
We also learned how to use ChatGPT like more effectively to complete our work, and use numerous YouTube videos to actually and tutorials to understand GearsBot. Because as of right now, we're like we had difficulties even like putting robots together and how to like interact with each other. So then, yeah.